And again, if you did forget to hand something in for whatever reason, anything, don't be afraid to talk to me. Okay? I've had people hand in the exam late because they had Wi-Fi issues, I understand, things happen. Okay? I understand that. All right. Okay, so let's do this one together. Good, okay. All right, so let's do this together. So, as I did recommend, right, what we can do is eliminate the denominators in the first equation. I mean, theoretically, you don't have to do that, but I recommend doing it. Because if you eliminate those denominators, it's going to make the work a little bit easier. Okay, so how do we eliminate those denominators? Well, they're both equal to 3, so let's just multiply by 3, as you can see. Doing so, right, once we distribute, which is what I'm doing here, we get 3 times x minus 3 times 1 over 3 times y is 3 times 11 over 3, as you can see. And so we get 3x. The 3's cancel here, right? We get y minus y. Here, we get 11. So we have now 3x minus y equals 11. So essentially, we transformed this system into this system. And we did it algebraically, okay? So we have this system to deal with. Now, if you look at the x's, you might be thinking, well, if we multiply the second equation by -3, right, and then add, then the x's would be gone. But we don't have to do that, right? And why don't we have to do that? Well, notice that the y's here are opposite in sign, so that if we add the equations, the y's would cancel. Right? We can see here that here we have negative y, here we have plus y, okay? If we added those two equations, the y's would cancel, and that's what I'm going to do here. So if we add them, minus y plus y, they're gone, okay? 3x and x, add them. So since we're adding the equations, the y's are gone, right? And since we're adding, we have to handle everything else. 3 times x plus x, right? That gets turned into 4x. 11 plus 1 becomes 12. So again, we're adding the equations together. And by adding them together, right, the y's cancel, the x's become 4x, these terms become 12. So the equation we get is 4x equals 12. That's our new equation. Okay? But we don't want 4x equals 2. We don't want 4 times x. We just want x. So what do? Well, we divide by 4. Divide both sides by 4. Right? So we have 4x over 4 equals 12 over 4. And we get x equals 3. Okay? So we get x equals 3. Now, are we done? Well, no, because remember, we have to figure out what y is. Okay? We have to figure out what y is. We can use either equation. I'm going to use, let me get to it. This one here is what I'm going to use. But really, you can use either equation. You just replace x by the number and calculate y. So I did x plus y equals 1. So I replace x by 3. Y is what we're looking for, and we have 1. So we have 3 plus y is 1. Okay, so what do we do next? Well, we got to solve for y. Although that's pretty easy, we just subtract, right? We subtract 3 from both sides, and we get y equals -2. So y equals -2. So we have x and y. Our solution then is 3, -2. And for fun, let's check it by graphing. We're going to use Desmos again. Okay, someone have a question? Oh. Right, someone actually, okay, so Daniel asked a really good question. If I don't write what method to use, do you have a choice? Yeah, I didn't write what method to use, so I should have been more specific with saying elimination. But if I don't tell you what method to use, you can use any method you want. On the final, though, what I'll say is use either elimination or substitution. I think it's because of Desmos asking you to solve it by graphing would be kind of silly because Desmos does all the work for you guys. So what I'll do is I'm focusing on elimination or substitution. So I don't think I was clear about using elimination. So I am sorry about that. But good question. Okay. So let me go to Desmos now. Okay. Here we go. There we go. Okay, now I gotta get rid of these. So let me graph it. So again, what I want to do is I want to put the equations into Desmos, okay? All right, well, if we go to let's go to them. Here we go. So we have x minus 1/3 times y equals, what is it, 11/3? 11/3. The other equation is just x plus y equals 1, as you can see. So can they see? Yes, you can. Okay, good. But you can see that there's only one solution. And what is that solution? Well, if you move the mouse over the point, you would get 3, -2, which is what we got. That's what we got. Okay. Okay. So that's what we get here. So there's only one solution. And again, our solution is 3, -2. So I figured it'd be good just to show it through Desmos as well. But let me now get back to the notes. Actually, before that, does anyone have any questions on this? Okay. All right. Let me stop and get back to the notes. Okay. All right. Just make sure can they see it? Should be sharing it. And here it comes. Good, good. All right. All right. So again, this was the graph that we just made. I mean, I wanted to go through making it in Desmos so you can see and have that on video when I post the videos, which I'm hoping is today. But you can see again that you have the point 3, -2 as the only solution. So next. Okay, so now again, I want to review a bit. I mean, I'm not sure if I went too fast in the course or not. I mean, I did cover a little bit more than I usually do. So I figured it wouldn't hurt to review. You know, I don't want to go too fast because if I go too fast, then nobody learns really anything. You know, then that's not helpful for anyone. So let's review a bit. And for now, I'll review a bit on trig. Because from my experience teaching this, people tend to have the most trouble with, well, maybe not the most, but people do have trouble with trig. So let me just review that for a bit. All right. Okay, so here, right, what we have is just the definition of the trig of the first 3 trig functions, sine, cosine, and tangent. You know, I'm just reminding you as to what those definitions are, right? You have SOHCAHTOA, basically. You know, you have SOHCAHTOA, basically. Okay? You know, we have opposite, hypotenuse, and adjacent. This is our angle theta. Theta is acute, meaning it's between 0 and 90 degrees. Okay. Now, let's do some work with this. Let's suppose that theta is acute. I know I didn't write it, and I should have, and I'm sorry I didn't. But we're supposing tangent of theta is 2 over 5. So tangent of theta is 2 over 5. We want to find all the other trig functions. That's what we want to do now. We're going to find all the